Hi everyone, can you hear me and how's the sound quality? Okay, great. So let's continue working on C++ stuff. All right, so previous time we took a look on loops and we took a look on literally probably the most simplified loop construction we can use, which is for construction. And this time we will take a look on probably we can take a look on both while and do while, because there will be even some small tasks. So, well, I suppose you will make them quite easily. All right, so I'm about to share my screen. All right, well, I suppose you can see that. Well, if only there will be some problems with the internet, you can tell me, then maybe I can then switch off the camera or maybe make a lower kind of bit rate of the sound because today we have here in Riga a bit problematic internet. So if any problems, let me know. All right, so the screen is shared. That's great. And here we have some additional files we can take a look this time. All right. First of all, I would like to take a look on the for loop, which you took a look on previously. And as you probably remember, guys, the for loop can be used, and actually was used by you guys previous time. In cases you approximately know, you could predict how many iterations you have to do, literally how many times you have to execute the code which is given as entity or as block of instructions to the for construction. Because what we do, we write initial statement of the for loop, we write conditional statement, we write even after iterational codes, which is pretty fine, pretty nice. So there is no any single problem with it. But we kind of a priori know how many iterations there will be. At least that's the way how programmers try to use for loop, and which is a bit not really correctly, because frankly saying, you can have even a lot of different variations of this loop. Well, for example, I will maybe copy this code, and I will try to show you a couple of things, which I suppose I didn't show you previous time. So I'll be using the C++ for sure. Well, and you can use compiler which you like more, if there is such. So I will be opening the source. Okay, for example, I have it and I will have to save it even somewhere. Well, let it be like this. So as you can see, guys, here the entire so within these brackets, it kind of we are given three instructions, and we don't finalize the third instruction by a semicolon. Does it look like that for you? Do you assume that looks like you just give three things and they're just separated with semicolon, like you're finalizing instruction? Does it look like that in for loop? That's quite fast question for you guys. So yes, so 100% it looks in that way, but in the same time, it's not really so, because okay, well, it wouldn't be problematic if you would if you would forget to place a semicolon for the last instruction into the block. Well, for example, like this. Most of compilers will allow us to compile it. Oh, okay, this compiler doesn't allow this, but most of them will allow you to do that. So a similar principle can be found out here, but in the same time, guys, you can have several instructions in every of this block. Okay, talking about the conditional, you just fulfill condition with some logical or maybe logical and, given additional condition and so on. But things related to these blocks is a bit more broader. So what do I mean? For example, you can fulfill this part with some other equations. For example, like this. So you can define both I and j, and in this case, you will have to separate them differently. For example, one of ways would be to use a comma. Okay, so yes, so we have to have j, or what we can do in addition, we can just declare that like this one. And as you can see, oh yeah, compiler doesn't allow that, so maybe we can declare that before, like this one. Yeah. So as you can see, once you have variable declared, you can operate with them quite simply. So these instructions will be just separated by the comment. That's it, and you can write tons of them, literally tons of them. In the similar case, so let's say we will fulfill this condition of stopping the loop using even j value. For example, j will be less or equal to 10, and we can even fulfill the the post-iterational block like this one. So they will be not just increasing of I, but even increasing of j. Yeah, so as you can see, it's compilable. Well, for sure we can try to think, oh well, if everything will be fine, well, literally everything will be fine. Let's maybe put another text here just to see that both values will be printed out and they will be the same. We can even put the new line symbol in the end of such printout. And let's maybe run that. So, as you can see, both values are just printed out and both of them are working nicely. And in a similar time, guys, you can even ignore placing some data inside all of these, or in few of these blocks. For example, we will ignore the initial block, so we will place nothing here, and it will be working well. So let's see. So you see, the codes are working without any problems, and we don't have any initialization code. We just prepared the values, initial values before the loop constructor. That's it. So in the similar manner, let's suppose we're taking out the block which will be used for post operations. And maybe we will do these things within the iteration. But again, it influences this for configurator. Okay, so let's see what will happen this time. Well, you see, nothing bad because things are working as it's planned. But guys, even this part can be taken out. So if we have this case, it means that the returnable value of the conditional block is always true when you put nothing there. But again, how to finalize the constructor? Well, we already know the finalization operator, and I suppose everyone can remember that, and it was break, which breaks the closest construction it's located in. So let's see how that will be working. Well, as you see, okay, wait a bit. No, it's the continuous. Okay, so it's the equation to continue iterations. So to interrupt that, it should be the opposite value. So that's why we can use exclamation sign, which means logical not. Okay, let's run it. Yeah, so you see again the same logics. Everything is done pretty smoothly, and the same result we have in the end. That's the idea. So you can use this for constructor in a pretty different ways. So you can make these tricks with this for loop. Okay, so that's the idea about how can we modify this for configurator. So are we good so far? Do we have any questions at this point? Okay, great. All right. So as you can see, for can be used quite in interesting way, but in the similar manner, there are two more ways how we can make looping, and those looping approaches will be a bit different. Yeah, let's hope we will overlook them both today. So let's take a look on the study materials we have. And we will be dealing with a loop constructor called while. So, idea here is super simple. You write condition, and the influence on this condition can happen within your iterational code. Literally, guys, it's the same as you would be having only the condition inside the for loop. So it's equivalent to this constructor we have on the screen right now. But how it will be written using a while constructor? So we use while. We take out those unnecessary semicolons, these ones, and that's it. That's literally it. We can even run it. Ah, yes, the semicolon for instructions missing. Yes, and as you can see, there is the result. So we have it. But let's take a look a bit closer how the while is being created. So, so if we have something we have to deal with, like initiating variables for conditional computation or whatever else, we have to do that before the while loop. Within the while loop, and by the way, a while loop can be infinite. So there could be the practical condition. Well, practical in this case means with the possibility to be so. So literally, there is a practical condition which can lead executional cursor to go out from the while loop, or there could be a condition within an iteration that literally breaks the while constructor. So both cases are fine. If we will be dealing with flowcharts, it will be working in such manner. So we have condition. If condition is true, then we run operators, and it goes in a loop. Once condition becomes false, then that's it. So we're finalizing this looping, and that's it. So let's take a look on example. Okay, we already have seen one, but let's take a look here. So let's suppose we have to write a program that prints all numbers and calculates their summation, which doesn't exceed 70 and divisible by 7. Okay, well, in this case, it's pretty simple. So 0 is divisible by 7 without the remainder, because the story here for such conditions is to have it without remainder. And then you see we don't really need to increase x by 1 on each of iterations, and then calculating if the x is divisible by 7 or not divisible. So we just increase that by 7 and that's it. Yeah, and at some certain point, the value will overcome a value of 69, because here we have the condition for execution of the iteration is that x is less than 70, so the maximum value is 69. So at some point the x value will overcome that 69, and at that moment another iteration will not be executed, and while construction will be just terminated. That's it. So as you can see by the printout of the program, we have such values included in the computations. And here we have a small table that basically shows a step-by-step values of x, if we need that. Well, I suppose idea here is super simple. Okay. So so let's suppose there would be another condition. So let's say we would need to make the program that prints on the screen all two-digit numbers that are divisible by 3 but not divisible by 2, and we will need to calculate their amount. So we have variable for the amount, we have while loop with the initial of the first two-digit value, which is 10 in that small numerical system. And then you see we have a if with the condition of finding out if value is divisible by 3 and not divisible by 2. And then we compute them, how many of such we have, and we print out each of them. In the end, we print how many of such numbers there were. Like what will be the output of the program? Well, the output will be such one. So firstly, this cout will be executed for each of the numbers, and then the cout which shows how many of such values we have. I suppose that would be a super simple one. So are we good so far? Okay. So let's return to materials. All right, so that's about this theoretical thing about a while loop. And while loop checks condition to run each of the iterations. So firstly iteration, then condition to run another iteration. No, well, firstly the condition, then first iteration, then the second time running condition, then if that's fine, then second time we are running iteration, and once it fails, well, no iteration is executed. Potentially the condition can fail from the very beginning. So for example, if x would be, I don't know, 999, then this condition will fail. So such iteration, which is highlighted here, will happen 0 times. So it will not happen at all. So firstly condition check, then iteration happens. Okay. So let's have few tasks for the while loop. Yeah. So again, you can write me about that you finished that, or you can just post some codes, or you can post some questions if you will have some. Okay, so write the program to print all numbers from A to B with the step of C. And A, B, and C will be entered by user. So a super simple application, actually. So guys, that will be the task for you, the first task. And I will be periodically switching to the chat to see if some of you posted maybe the code or maybe the info that you've done the task. Oh, really? Well, I thought that we have tasks related to while loop, not for loop. Also, this you mixed something. So please remake that with while loop. So again, guys, once you will have results, please let me know so I would know that you finished the first task. Okay, I'm just a bit surprised why it takes so much time. Guys, do we need to take a look on the first? Do we need to make a solution for the first task together? Well, the while loops are pretty frequently used, especially when work happens with drivers and robotic details, programmable details. Um, for example, everyone knows the robot Roomba, isn't it? Like vacuum cleaner robot Roomba, very popular. The base of its code literally is written on infinite while loop. Well, just an example. Okay, guys. Anyways, do we need to make first task together? What would you say? Mm-hmm. All right. So I will maybe try to convert the code of Oswaldus. Because it's pretty close to the result. So we enter numbers. That's awesome. and what we do, we say, okay, there will be iterable variable a, or guys, we can even not to do that. We can literally say, um, if well, for the cases when a is when a is less than or equal to b, then we print value a and we increase a by c. Well, it will be a is equal to a plus c, like this one. Okay, let's run it. Yes. Instead of while, sorry, instead of for, there should be while. Yeah. Okay, and we can run it. Okay, let's say we are going from 1, we are going to 10 with a step of 3. Well, 1, 4, 7, 10. So that's the way how you can make that. Okay, I will copy the code just in case. So as you can see, it's doable pretty simple. And if there will be the case when you would like to have a middle variable for this purpose, for iteration, then what can we do? Then we can make a variable like int I. It will be equal to a. Then we will be dealing with I in the condition. Then we will be printing I, and then we will be increasing the value of I. So like this. Now, well, in reality, almost nothing has changed. The only thing you just include one more variable, and that's it. So this is the idea. So are we good with this solution? Is everything clear so far? Okay. Since we've done the first one, I mean the task. So I suppose I can give you the second task. Well, it's kind of childish computations. So you have amount of blocks, and you need to find out how many floors of the pyramid you can build. And this is the two-dimensional pyramid um, made from cubes. And here we have examples of how many cubes it will be needed for the first, second, and third floors. Well, I suppose you will find out the proportion, and you will find out the equation that connects floor and amount of needed blocks for the floor. And surely you can use a while loop for this solution. Okay, guys, take your time and please solve the second task. Okay, so I see that also this made the solution. Okay, let's take a look. Oh my. But what if you would have 0 blocks? Would you be able to count from the first floor? Okay, anyways, late for others as well. Maybe there will be some other solutions. Yes, hold on. You probably didn't get my idea. What if amount of will be 0? In your case, even if it will be 0, amount of floor will be 1. As far as I see. No, wait. You print floor minus minus 1. Okay. So while doing this, we will maybe show what we will have here. Let's have 10 cube. Okay. Divide over 100. 6 floors. Okay. Okay, what's your application? Give me if I will 91. You build a pyramid. Yeah, but house. No, I suppose this is quite okay. So the for others then I'm not solve this. So how are you with the task solution? Okay, no answers in the chat, right? Then I assume we can move forward. Okay. Well, guys, you have to answer the questions when you asked. But okay, how would I solve this? I would just have cubes and 4. That would be fine. This part most likely will be just erased. Same as this one. Same as -1. Okay. So if you have amount of cubes which is at least the square of the floor, which means which will be the floor, which is the next from the already built one. Or let's see, which will mean the next. Here we can make maybe multiplication, and that's it. So if it happens, they increase amount of floors, and we decrease amount of cubes. Oh yeah, well by the multiply it with 4, and that's it. And now, if we will, for example, try to check if we have 100 blocks, it will be enough to build 6 floors. Yes, it's so. Okay, and we had 91, and you see, you still have a result. So, so that's the idea. So I would definitely make it this way. Okay. So I suppose we can take a look on the next task. So write a program that asks a user to enter the number and determines how many digits and entered by the user, and calculates the summation obtained by adding the digits to the entered numbers. So, which means if you have let me take a look again on that formulation. Yes. If you have maybe a ABC number, an ABC would be an ABC would be just your decimal number which contains 3 of digits. So the result about the summation, it will be itself plus A plus B plus C. So literally using the values of the number in the manner of the lowest part of the numbers here. A very interesting thing, but okay, how would it be possible to calculate this? Um, so the question could be, how can you split number in different symbols? Probably you can use, for example, reminder after division. So maybe you can use that. So who already started to make the third task? So is there any progress related to task number three? Mm-hmm. Okay, so if you like, you can even share that. Okay, guys, maybe some few more minutes, and then we'll be looking on the how to solve the next task. I mean, how to solve the task number 3. Okay, so we have some results from all students. Okay, okay, I will maybe take that solution and put in the code editor. Right. Oh, wait a bit. It wasn't correct one, probably. Okay, so I'm taking that. Yes. So digit sum a number. Okay, entering a number is good. Okay, fine. Next line. So temporary 0. Um, okay, so digit sign increased and okay, so literally it will be that way. Then temp becomes a number if temp not equal to a 0. Okay, interesting solution. Okay, so in this code, I literally see another while, and maybe there's separation between good execution and bad execution. So here we always receive a digit from a number. Literally in this case, we just chop in the value from so-called dollar meaning part. Okay, so summation will add its values. Temporary will decrease its values. Okay, maybe we can take a look. Well, I suppose this part is much more correctly done. What if I will just, this out? Here we have the int. Okay. So let's suppose I have 123. Okay, so the result is 6. If I'm having, I don't know, maybe 666, so result will be 18. Well, yes. Well, yes. Okay, let's take a look on maybe another task because these things are quite simple. Okay, so another one. So we have to make the program that computes two integers as an input of the user and finds the greatest common factor. Well, it means the greatest divisible, which can be used for both of these numbers. Well, we can take a look on how it can be created, but I suppose that we can change something um, in task actually, just to make it more interesting. or maybe we can just forget about this task. Well, yes, let's do that. Okay, so since we took a look on how this while constructor uses, we can take a look at least a bit on another one, which is super simple, super close to the while, but with only one difference. Okay, so literally, as you can see by the syntax, as we right do, then we have an entity. Well, literally iterational variables here we have. Then we have while and the condition. So if we would try to do this if we would have just the one if we would just have one instruction, we would just be placing it without these brackets, without the curly brackets. Okay, in the flowcharts way it looks in a such way. So we have some operators, we have some conditions. Oops, I didn't translate this picture, but I suppose things are understandable. Operators, condition, true branch, false branch. So that's the way how it executes. So firstly it executes and then checks if it can run next iteration. After which, in the end, there will be another I kind of lost my idea. So firstly you do, then you check if you can do operators another time. Okay, so let's say we have the program that sums all even numbers and which is entered by the user. If the user enters the odd number, the program stops counting even numbers. So what you're doing, you're just counting or summating even numbers, right? So we're about to type, and if we the remainder of division by 2 is a 0, then it's the even number. So we're making summation. Okay. Okay, so here we have a small description table of how happens the computation of the program. And what is interesting, maybe the most interesting thing, that you can literally work with different cycles, and you can use them Well, I wouldn't say simultaneously, but you can have one constructor in inside another constructor, and it's pretty normal. Yeah. So the only thing you have to remember, you cannot really do the following. So you cannot really cross mm, the beginnings and endings of code blocks. Okay, so here we have an example, which sounds in the following way. So there is some social research, and literally it's about if residents support the installation of something. Well, literally it's about some event which will happen there. So agent needs to ask opinion of five houses residents in each. So each house has four flats, and while a program, and we need to make the program that allows to enter every respondent number. And if respondent yes, then it enters one. If no, then minus one. But if no one was at home, then they enter in a zero. And in the best case scenario, we need to show the result in the graph, but it's not really needed at this point. So how to organize such computations? Well, very simple. So we just have to have several. We have to have several um, variables to store indexes, to store two-dimensional points. Okay, so we have external loop, we have the inner loop. Okay, so this is how that application works. Mm-hmm. Well, overall that's it. Um, okay, let's maybe take a look on some at least small tasks which can be done. Okay, and for example, I can ask you to solve maybe the task number. Okay, maybe number one by the do while. So again, it's not by for, it's not by while. So you have to use the do while for the first task. Yeah, this one. Okay, okay, and no results. Okay. Maybe I will ask who is in the progress of that second task of do while task section. Who is trying to make that? Is there anyone? Okay, okay. So if things are not going well, or well, guys, please, don't keep silence. Otherwise, I'm thinking like, okay, maybe you're doing, and if only you would just, if only the most of you would just write that, okay, well, it's a bit complicated, then we already would make that together. Okay, so since Lorenas is the only person who wrote, so I suppose that others are not working on it. Okay, so let's take a look how we can make it. So what do we have? Well, it's the classical task of the timing and collecting results after the timing. So we have an onions, um, and we know that the onion, one of onions, makes three onions during a year. So we have to make the program that determines how many years the landlord who bought those initial onions should grow the onions in order to reach K onions. If on and there is the condition, and the condition says that none of the onions were taken out from the grid, and none of them died through this process. Well, idea is super simple. Do while. So let's make the numbers. So let's say onion will be n, and amount of years will be G. Yeah. Oh, and we need to know the threshold. Okay. Okay. So let's suppose we'll just give some values. Okay. Initial onion is only one, right? And we need to reach, for example, 100 of such. Okay. So what should we do? Well, we are using a do while. In which condition we need to write the condition to execute next iteration. So it will be n didn't reach k. So n, which is current amount of onions, didn't reach the value of k, the amount of needed ones. And here, what we are writing inside. So here we calculate in each year, right? So when we do that, Initially, we have to say that, well, there are 0 years spent. Okay, so 0 years spent. Okay, if that's so, during each iteration will be increasing amount of years spent for computations. And in the same time, what we know that that during the year, total amount of onions will be the previous one. So n is equal to n plus n multiplied with 3, because we know that each onion gives us 3 new onions, right? So in this case, if we have if we had only one onion, then after first year, what we do? Well, we receive 4. Then, when we have 4, how many of them we receive the next year? Well, 4 plus plus 12. Okay, anyways, so we'll be counting them, and in the end, we would need to print out amount of years. So let's print them out like this one, and let's see how many of such will be spent. Okay, let's run it. Yeah, so you see, literally 4 years. Well, we can even print stuff out if we like. See out. Then let's suppose we'll have year. We'll put that on after, well, before the bracket. Next, we will say we have value of n. Okay. And it goes from initial n till this one. So we can add the printout in a such way, and we can put a new line or something like this. So let's see what will happen in the printout. Yeah, so you see, on the first year from we reach till 4, on the second from 4 till 16, from 16 we reach to 64, from 64 we reach to 256. So all the 4 years had to be spent on that. Okay, I will copy maybe these codes in our chat, because it might happen you will need them. Who knows? And maybe it's okay. It's already 8 o'clock, so so I suppose it's the time for Q&As. Now, do we have any questions related to today overlooked modification of for loop, while, and do while? Okay, was everything clear for you guys? Can we say that we received the knowledge which we understood and understood well? Okay, great. So again, guys, I would really like to encourage you to ask questions if something is not really fine. And in any case, guys, if I'm asking to put something in the chat, some answers, so guys, please don't be shy to do that. Otherwise, it's not really clear for me if we can move forward in materials, or I have to wait a bit, or what is just happening, you know. So guys, I know that sometimes we don't really like to communicate maybe, but please during the classes try to answer the questions. Okay guys, so it was nice that that you were in a really big group today. It's really nice. Hopefully, I will see you next time in the group which is not smaller than today's group. All right. So, guys, for those who didn't make assignments, please at least find a time to start them. And I suppose in a week, during the week, I will check those assignments which are submitted already. Okay, guys. So I suppose that could be all for today. Thanks for being connected. I really appreciate this. And next time we'll take a look on another very interesting things related to C++. Okay, guys. Thanks again for being here and welcomed. Be here all times we have classes. Okay, guys. Have a nice evening and see you next time. Bye bye.